cross-sectional area to create the char. It's just going to ignite. I don't have red marker. That's that on fire. So anyway, that's an important distinction to know, because what you're starting to see in our industry is that people are exploring timber a lot more. And if you're hearing that word timber, heavy timber, mass timber, this is what this means, right? It's a different type of building product. With masonry, very rarely are we building buildings out of brick and CMU block anymore. It's just not a thing that happens. But back in the day, when we're building, skyscrapers in Chicago, this was a very common way, mixed with timber, to build these buildings. So what do you think is more common, steel or concrete these days? Or do you think that's a loaded question?
It's loaded.
Why do you think it's loaded?
Maybe a combination of both?
Still the chance for a good pun.
Porque no los dos, as you say.
Because you're using steel to hold up concrete on top of steel decking.
So you're saying what you imagine is that it's mostly a composite use of the product?
Yeah, that's my guess.
Yeah, well, I mean, steel and concrete are used ubiquitously in construction. But I guess if I were to ask, what are more common, concrete columns or steel columns? Ooh, now I'm getting specific.
Concrete.
Do you think this building has concrete columns?
I think maybe I think steel is more common now.
Yeah, now?
I think steel is
Yeah.
more common.
Yes. Necessary inclusion of the word now.
So, one of the things that's interesting about these products is that they go in order of their typology. Building type 5 and 4, you have building type 3, building type 2, and building type 1 in Roman numerals. And anything that's over here is what they call combustible. And this is what you call non-combustible. Now let's think about the products that we're using here, Augustine, before you write a letter to the mayor, whatever you're doing over there. What are you doing? You writing notes?
I'm trying to log in. I've been trying to log in this whole time. I swear.
So so speaking about fire, what do you think the differences in performance are going to be between steel and concrete? Yeah, this is a conversation. It's not like you read a book and you're experts at this. I'm just trying to get a conversation.
Concrete is more fire resistant than steel.
You sure about that?
It's my opinion.
Well, why is that?
It's just I'm thinking of steel and it bending and it losing.
Bending.
Yeah.
So
Resistance,
if I have a wide flange beam, right, and it gets subject to fire, you're saying I have a potential chance that it starts to sag and lose its resistivity to the force, right? Is that what you're saying?
Yeah.
But if I have concrete piers, which I'll move out of the way in a minute, that's more resistant in a fire. Is that what your claim is?
It's not. I wouldn't call it a claim.
Whatever you want to call it.
It's a hypothesis.
Well, it's the same difference. A claim doesn't have to be true or not. It's just a claim. Dan, do you agree or disagree with his claim?
I agree with his hypothesis.
Whatever. Said. Yes, that is actually true. Does anyone have any idea how tall you think you could build with a steel structure?
Oh,
As tall as the Empire State Building.
Interesting.
As tall as the one that's what is that, vertically?
Okay.
Maybe taller than that.
So you think those are all made out of just steel?
Not just steel.
That was concrete, I think, actually.
Oh, that one's not.
well,
The Empire State Building is made out of metal.
Can I ask the question? What the difference is between those two?
Maybe now you're going to say wood, I don't know.
Is it made out of concrete or is it made out of metal?
Both.
What's your question?
When does a building become steel? Considered a steel building, or when is a building? When is it
What
considered
are
a
the
concrete?
columns made out of? In a nutshell, that's what I'm asking.
Aren't columns always steel and concrete?
No,
No?
no, no, they're not. You can have a building that's just steel columns. You can have buildings that are just concrete columns.
Don't they have, okay, so the buildings don't have some sort of concrete around the beams at all?
It depends on the building.
There is rebar in the concrete.
Is that what you're
columns,
asking
though.
about rebar? Or are you talking about what's in the
No,
case?
I'm talking about beams, I-beams, big I-beams. Those are typically not covered. They don't cover those.
Not with like anything. The structural integrity is going through the metal.
Okay.
That's what he's getting at.
Okay.
Yeah, you probably have infills with something.
'Cause I thought even steel buildings like this one, for example, I know that when it was bare bones, it was just steel beams everywhere. I thought on top of that they put concrete.
Maybe he's thinking of like concrete on a metal deck. That's what I think he's going
right
at.
there.
Huh?
The one you asking is right there. I love how you're like talking.
No, that's what he just said. That's what he explained. He said concrete on top of it.
I might be getting confused myself.
Well, I'm even more.
Professor, I forgot to ask you, do you mind if I record the class so we can remember?
Go ahead. Do it quickly.
Thank you.
You see that? Okay, you want me to close these? So in the IBC, International Building Code, which the United States pretty ubiquitously follows to this day, not historically, of course, it didn't exist, but it used to be called the Vocal Code. You have a chart, and this is sort of like the Bible for an architect with their ownership team at the beginning. To say, okay, I have a building that's made out of wood. Okay? I have a building that's made out of timber. I have a building that's made out of masonry, steel, or concrete. And this is what I'm doing inside the building. And you kind of follow along if the building is sprinklered or not sprinklered, an S or S. What is the height at which I'm willing to build out of that material? Okay? So if it's unlimited, it would be UL. And if it's got some sort of ceiling to it, it will be a number. So if you look at this chart, business or an office building that's made out of wood, you're actually able to build a wood building that is, a business use up to 3 stories. If I do it out of heavy timber, you'll see that the codes are starting to change. I'm actually able to build pretty tall if I meet certain requirements, and there's a subclassification of A. I can build up to 18 stories, but if it's not sprinklered, I'm only able to build up to 5. You can see it's pretty capped. Steel, interestingly enough, I'm in the wrong category. If it's sprinklered, I can only build 4 stories high. That's with steel, structural steel. Now, you'll see here, you might be asking, what is the difference between these numbers and letters? If I just take a naked piece of steel and erect it and put it in a building, and I do whatever, that's what we call a unprotected assembly. And that would be a type 2B. So if I had a steel building that was not applying fire coating to it, that would be a 2B building, which means if it's sprinklered, I'm able to build up to 4 stories. Now, technically, this is 4 stories above grade, which is confusing to people because that means it's a 5-story building. Because we usually count the G level as being level 1, right? So I'm talking about I can have 1 more story above grade. So I start counting at that. But then if I go to concrete, I'm able to go up to 12 stories. And if I protect that concrete with an additional fire rating, I can build up as high as I want. So in other words, even though we think of steel as being pretty much as strong or almost as strong as concrete, the difference in fire resistivity for life safety reasons makes it almost impossible to build anything out of concrete that's more than 6 stories. Does that make sense? Now, if I do apartment buildings, which is an R use, the table's a little bit different. R2, D2. You'll see here, I'm able to build 4 or 5-story buildings with that as well. You'll see there is actually something called an S13R system. That means that it's got limited sprinkler coverage. Anyone here have a house or apartment that has like a few sprinkler heads in your unit? No? The new place? Old place does? Usually that's gonna be a 13R system that is allowing you to escape, but not necessarily protecting your property. So if you ever hear the term 13R, it's referring to the NFPA 13, which has a subsection for residential coverage, which is the R section. So I either have an NFPA 13 or I have an NFPA 13R. And if you do an NFPA 13R, you're gonna put a lot fewer sprinkler heads in, you don't need as much pressure, and it's designed to let you get out, but not necessarily save your property and save the building. All of this context to tell you that we have to be very careful about what we're expecting to do in our building. Are all our buildings less than 4 stories? Yes, I hope. I don't think anyone made the Tower of Babel on me, right? Yeah? Does anybody feel like they are able to build it out of wood based on what we're talking about?
Yes.
Okay? So technically, if you wanted to, you can build your building out of wood. If we go back to the use chart, you'll see the other thing you have to be keeping in mind is how many square feet you can build. There's another chart for that. So if I have an office building and it's made out of wood, I'm able to have a floor plate that's about 18,000 square feet. Now, we're nowhere near that, right? So we don't have to worry about it. But that's actually cut off. If you look at the chart, we actually have a limit of 9,000 square feet. For some reason, it cuts it off, so I can't show you that. All this to say, I want to start our project by everyone building something out of steel. So our subframe structure should be a steel building. Now the question for you is, how do you get started showing how you're going to frame out that building? What do you think?
A grid?
Yeah, you might look at your floor plate and start to assign a grid. Then the first obvious question will be, what is my column spacing? Right? So what is our average on anyone's project? If I were to ask you, what are your overall dimensions for your whole building? Are they at 120 by 80? What do you got?
by 120.
Wow, nice. How about you, Sid? Okay. And you, Augustine?
Let me get back to you on that, please.
What do you mean? Just measure it.
I don't have the project open.
What have you been doing this whole time? You at least recording?
Yep.
So, what do you think, based on what you understand for buildings, is a typical column space? You ever thought about it? I go home at night, that's all I think about.
I remember, because I did a project, I figured.
You know how wide this room is? Gotta teach you how to figure it out.
That's, how many inches is one of those tiles?
2 tiles, 2 by 2. So how is it 30? Did you count or did you lose count?
I was waiting to say that.
Of course you can. That's all the strategy of the column. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, you're right, it's 30 feet. Now, technically there's a drywall soffit, so it's a little bit bigger. But let's just say between friends, this room is about 35 by 35. give or take. Okay. Now, where are the columns in this room? There's probably one in that guy because it bumps out. There's probably one in that guy too, right? Because it bumps out. So it's fair to say, from nose to tail, center line to center line, we're looking at about a distance of 30 on center. Okay? So that's not a bad place to start. And a lot of your projects are actually kind of divisible by that. At least the two that gave me their dimensions. Okay? So if I divide both these numbers into 30, that's easy, right? What is that?
What are you asking me?
Yeah, it's 4. I just want to make sure you were with us. So if I have a 20 by 20 cube,
That was
120.
cruel.
Huh?
That was cruel.
Pretty cool. So you're saying this is your column grid. Something like that.
Something like that.
And then SIDS would be something like this. 150 is another layer. Okay? I don't know why I went the other direction. And 60 is just 2 that way. Now, unfortunately, SID, my suspicion is that's going to be problematic. Now, there's something about steel that's interesting. The reason why structural steel has become in vogue is because it is relatively lightweight compared to its friend concrete, and it's really easy to substitute different sizes and weld and bolt things together, right? And so the rule generally is you can make spans as long as you like, as long as you have the headspace to make beams that can go pretty far, right? If I get a member that's deeper like this, I can actually span larger distances. So typically this would be a girder, or this would be a beam, or maybe a column, right? So this is what's holding a lot of the weight. But the first step is to set up a grid, to understand where our columns are going to live. So before I even inundate you with, well, let's pick what size, or let's do this, and we can model it, look at your models, and in drafting lines on a plan, you can take your, let's just do it this way. We'll take our first and second floors, we can make copies of them, and before we leave class today, we'll show where we want our column lines to go. Okay, so let's do that based on our intel. Augustine, what's your column structure?
It's gonna be. Oh man, 1 second.
No, tell me. What's the dimension of your building?
I
I need
opened
to
it.
look at what's on your screen. No more Mr. Nice Professor.
I thought I opened it.
Make those duplicates, start to look. My suspicion is it won't work, right? So then you have to ask yourself, do I have to tweak my column design, right? Do I have to maybe add another column layer? This is the kind of stuff that happens in real life.
Un segundo.
Un segundo.
Un segundo, por favor, mi amigo.
What's that?
To,
To do this, you can do this on your original model for now. This is just to learn where you're going to put things, just to see how it all works. Listen, what am I waiting for? Like you're not even close to showing me your plan. So you got that little courtyard, dude.
Yeah, and I got like 3 of them.
Uh-huh.
Where's the drafting line button again?
Show you in a minute.
Okay.
Where was that? I'll show you all in a minute.
And let's see.
Alright, so
Show me your plan.
I don't have this beautiful file right
Why
here.
don't? Why don't you?
Why don't I? At least you can see You don't want to see this?
No, because I don't see your plan.
Please be complete.
Okay, so go on to drafting lines, go to annotate, detail lines here.
Cool. Thank you.
Annotate, detail line. And again, you kind of see after you space them out how it's going to work. Now, key note here, they don't have to align to a wall. Buildings these days, the structure is not embedded in the front walls. It sits backwards from it. This is called a curtain wall building, right? In which the walls on the exterior are not load bearing. So this building, as much as it looks like a brick building, it's kind of an illusion. The brick is just there for the prettiness of it. It's not there to support the building.
Did you stick around for break, Professor, or did you have a little time off?
Well, I had time off, but I still worked. That's what guys. I
Yeah.
worked for real work. Yeah. Thank you for asking, because I had a miserable existence.
Nice.
Yeah. I enjoy my work. Actually. I'm just saying that. It was nice to have a break from you guys, not because of you guys, but just because I didn't have to one less thing to. Hope everyone stayed healthy and everyone's getting sick also. What did your mom think of San Diego?
While I was in the conference, she was exploring the city, so she loved it.
There you go, so I'm sharing my screen. So the first step is again to use the drafting lines to kind of figure out where you want the stuff to go in your model. I guess my first question for you as you do this, are you seeing any obvious conflicts? Or is it sort of working?
Yes.
Yeah, it's already having working. It's not working or it is.
Both. Some areas are going to be easier than others.
before you go ahead and re-engineer anything, we could talk about how you can have a building be majority on the grid and then modify in certain areas. So that's completely kosher. You can do that. So don't like completely go, it's not working.
Like how far off could a CMU face be, like 6 feet? 7?
Let me see what we got. The shoes.
Thanks. So the grid works fine for these two sections.
Except that one room. It's in that room. Oh, it's just electrical. It's fine. Servery? Is that a word?
Thought so.
Okay, so this one won't have a column in it. This will probably just be a load bearing CMU wall.
Sweet. But I'll still need something.
You'll still need it
Maybe
there.
so.
What will probably happen is that this will want a line here,
Mhm.
and then this will be another line here. So you'll do different policies.
One here, you said one there.
On the edge, you need your building to be supported on the edge.
I hope so.
Well, you don't show a line there. Do you? I don't see it. What's your spacing here? What is that? Is that it's probably like 20 feet, right?
From where to where?
From this line you drew to that line. 21.
29, but that's not, it's not, yeah, 29.
Well, your spacing before must have been more than 30.
Some pieces were, but they were close to 30. I think that's 30 and a half. It's 34.
Well, to me, this line should be in line with that, and that way it's closer to 30. And that's probably 30, so you probably want your lines to align with the face of your wall. There's a huge no, don't work against your building.
I kind of, maybe I thought I was,
Like your trucks.
no, I thought I was working with it, maybe I was accidentally.
Are we doing said?
So like that one's close.
So. Zoom back in.
These are 25 right here. Because this is 50 from this one to this one.
Yeah, that makes sense. Yeah, you got yourself a grid.
Nice.
I think it's not bad. Except this line needs to be here. Otherwise, it goes back away.
So we're going to 30.
You want to align with the wall. So what's that now?
34.
What's the other one? Oh, that one or that one? So here, here's 30.
Yep.
Zoom back over. Let's see what that is. I think that's acceptable for the building. That will, of course, hit shaft. And your probably better for your design if these all shift over. If you want this spine to be, see like a column would have to be in there.
Mm-hmm.
Probably want to move that line to the columns in that corner here. On the outside of the elevator.
Like that.
Yeah, and that way, yeah, that would be perfect. And now, how does it work upstairs?
Well, this is going through this elevator now.
Yeah, but that doesn't matter, because you can, as long as these columns are square the rest of the floor, these can be openings. This is not gonna be there.
You're saying this wouldn't be a beam connecting
It would
these
not
two
be a
columns?
No, all the better, you have a column here and a column here, and that way you don't even worry about it.
Cool.
You understand?
Yep.
How's it work upstairs?
I'm sorry?
How's it work on the second?
I'm hoping good. I'm pea brain. I was thinking in 1D or 2D, not 3D.
So if you did the same rules.
I just copy
Hey,
it.
hey, 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 I'm gonna teach you how to do this, don't do anything. Just finesse that for a minute, I'll let you know how to do the next step.
Sweet. That's
Okay.
the best thing ever knowing. I have a trick for that.
Hey, Ghostin.
So I can't find my project, so I just did a new one, just like you did.
I thought we had this problem 3 weeks ago.
I have it in my main computer at home. No, but we didn't have this project. We didn't have this problem here where I don't have my actual project here. I used to have my project here. I don't. Anyways, I have it anyways.
Okay. Well, let's just take good notes and you can apply to your project at home.
Yeah.
They're calling me, look. Does it work? Does it hit anything?
Probably, yeah.
Well, that's all I'm asking.
So annoying.
That room, the stupid room. This room was go up a little bit. That one kind of clears everything, that should be okay. Go up there. That's in the warehouse. Yeah, I think yours works, right?
Yeah, I think, yeah, actually,
Yeah, please do them. Sweet, all right. Thermoplastics. Okay, so after you did your drafting lines, now you have the opportunity to add something that I don't think we've done yet in this class. I go to the architecture band, or first tab. You see how those walls or whatever go all the way to the end. You see this one that says grid. It says here, place column grids in the design building design. So if I click it, now it says enter the grid start point. So I can go wherever I'd like. I can go on the end of a line and then do this. Now, usually you want this line to extend way past the building, so it like kind of isn't cluttered. You can then take your copy, go up, go down, wherever your lines are. And then I go to grid again, pick this line, do that. Now, note, before you get too carried away, typically in column grid design, our length this way is one thing, and our length this way is another in terms of its designation. It's a number, letter, or coordination. That way I can say any column based on its combination of letters and numbers. So in order for me to have Revit be smart enough, I have to take this one first and change the name. So I'm going to call it A. And when I do that, now when I click column A and I make a copy, it's going to automatically make them letters.
And I'm sorry, was this under Annotate?
It's under architecture.
architecture.
And watch what happens, Padilla. This is why I told you to wait. You go to the second floor, boom.
Nice.
It lives on every level. This is critical because you don't want to have to be like, I think like this column's here, right? Because that's what leads to disaster. Capiche?
Capiche.
make it to that breakfast.
Yes. Yeah, I made it to the
At
breakfast.
Donohoe?
Yes. I'll be happy to put you in contact. I should actually send an email with Donahoe with the internships that they're offering. Incredible office. They have so many employees. Like, they look really, really good.
It was good though, the breakfast? No, not the food, but like the people. Like, was it organized well by them? Because they kind of made it feel like it was going to be kind of last minute.
Like, it was what?
It'd be possibly like a last minute thing. I don't know if they just notified us about it late or what.
They had to change the office because they had a problem with something going on.
Oh.
But the office building was incredible. Like seriously, great office building. That I actually think they worked on. Like, I think
Yeah, they own it.
But I think they actually also built it. They didn't mention that, and I forgot to ask, to be honest. But yeah, it was good. Good networking for sure.
Sweet.
And the gentleman who did the talk, he was also very knowledgeable. Gave some pretty good. Didn't I see you guys in an email, like summarizing everything? I did.
I didn't see one.
I don't think I saw that either.
I made a LinkedIn post. Yeah, and basically summarized everything. It's just he gave some pretty good tips on if you want to be like if you have a entrepreneurial mindset. We can talk afterwards, but it was pretty good event.
Cool. Was there a lot of people from our school there? I know Percy wanted to go.
Percy is the Asian kid. I forgot what his name is. He's Chinese. I forgot his name. What's his name? He's in the class with Dr. K. You know what I'm talking about?
John?
Is that his name? John? Asian kid. He's the only Asian kid in the construction. Like the whole program. Quiet kid. Very nice.
Paul, right?
Yeah.
Yeah, I think that's John.
Yeah. He was there too.
Yeah, no, I did go back for RSVP and I'm not going.
Did anyone else go besides you two?
From the construction program here, I didn't see anybody else. No. There were other people from like different construction companies. It wasn't a big event. It was more like maybe 20 people, 30 people event.
Nice. Oh, that's kind of perfect.
So just so you have a sense of like what's typical. So this chart here is showing us about, let me explain it first. So if you don't know, which we would have no reason to know, in steel designations, the W is referring to the fact that it's a type of beam. What a lot of people call an I-beam is called a W flange beam or a Y beam. That's what the W is. The 8 is indicating its nominal height. So if I were to draw a dimension here, nominally, any beam or column that has a W8 designation should be about 8 inches. It's never going to be exactly 8 inches. And between every beam, there will be differences. This has to do with how they make it. If you don't know, what happens is on an assembly line, they have a hot plug of a solid thing of steel, and they take a roller to it, and they roll over and over and over and over again until it erodes and makes the shape. That's how we get that shape. So basically, the W is referring to the fact that it had a W8 roller in it, and that's how you got to that shape. Now, if it's a huge beam, the next number, meaning its weight per linear foot, so that would be 10. That would mean if I took a cross section of steel for 1 full foot, this distance, and put it on a scale, it would be 10 pounds. That's what a W810 would be. Okay? If I took a cross section of it for a foot, put it on a scale, it would be 10 pounds. So in other words, the W8 will always mean it's about 8 inches, but you'll see here it says nominal size versus its depth. So it's going 8, 8, 8, 8. But you'll see the fatter it gets, the more weight it has on it, the deeper it has to get. right? Or the wider it has to get rather in order to accommodate for that weight. Otherwise, it's not going to be able to make up for that linear weight. So, you'll see a trend. The deeper and the heavier the beam, the more my beam can hold. So the top axis here is the span, anywhere from 8 feet to 26 feet. Now we just got done talking about how we're doing spans of 30 feet. Why am I showing you this? Well, I just want us to be realistic. If we start to position different beams in our project, we have to make sure our beams are going to be at least W12s and that they are 36 or 35 pounds per linear foot, because that is just barely getting us to what the allowable span would be, which would be 26 feet in this little chart here. Is everyone following? So if I make the beam deeper, and I make the beam heavier, it can support more and more weight. You'll see the actual data on this chart is what's called a uniform allowable load. So this is an important distinction. This isn't a point load. This is as if the load is distributed across the entire element. Because point loads can be pretty heavy and cause a failure. But typically these are in the thousands of pounds. Okay? So you'll see here it says kilonewtons or pounds. We have it in pounds. This is going to be how many pounds over the course of the thing. This is usually going to be measured in kips or kilopounds, ironically, which is measured in thousands. So my allowable, for the most allowable one here, 2800, I'm allowed to carry about 28 kips. Okay? So this is pretty standard way of looking at these things. You'll see that if I go down the chart, back towards the smaller elements, they can't hold as many uniformly. So there's all sorts of charts and things that exist to talk about these. I don't need us to become experts at it, but I need us to understand the basic fundamental premise, which is that if I start to put in elements on my column grid, I have some sense of what they're allowed to support. So if we have our column grids in, and we're on level 1, if we're just in our actual models for now, we don't have to make a secondary model just for the sake of keeping it simple. We can go to systems.
Could you refresh your page, Professor, please? Thank you so much.
How do I do that?
Just stop sharing and start sharing again. There you go. Thank you so much.
Oh, shoot.
Thanks.
Did that work? You see that?
Yep. Thank you.
So I go to systems. You'll see that nothing here about structure exists. That's because it has its own tab, extra architecture. You'll see I have beam, wall, and columns, and they're all possible under structure. So in the case of, say, Padilla's design, where he has some stair towers that are on the exterior, you could maybe draw those walls as being structural walls, right? That actually have a bearing on them. But in this instance, I want to keep it simple, and we'll talk about beams and columns. So I go to column, I go to properties. I already have a W shape already loaded into my model. You'll see here I have concrete columns. If I want to go concrete, I have what's called a hollow steel tube, which is an HSS structural steel. Or I have my shapes, my columns. Now I just got done talking about how my beams are going to be probably nominally 12 or big or deeper. So I don't want my columns to be too small. So I think I'm going to go with a 10 that's 49. Again, this is me just blaming. And you'll see it will automatically load it on my cursor, and I can get it to be aligned to where these column lines meet. And you'll see it says none of these elements are visible. And that's because usually on our visibility graphics, well, there's actually two things that might be happening before we get too far. So I go to my project browser and I go to my 3D view. common thing that happens after you set a column down. It puts it below the level you were on. So I have to select the column I was on in properties, and you'll see the culprit. It has a base offset. So if I take the base offset out, put it at 0, I have to take the top level and change it to 2 before I change this back to 0. Now if I go back to my project browser on level 1, now suddenly you'll see that my columns are there. My column is there.
So you change the top level to level 2, and then you base offset to 0.
Correct.
Boom, fixed. Boom.
So you want to do is take your structural steel, make your copy, follow the lines, get those two hickeys to live where they want to.
That's awesome.
And again, most of your columns are going to be generally about the same size. You might have ones that are going to be different, but just for the sake of this model, we'll keep them the same. So if I made a bunch of copies of it, when I go back to my 3D view, you should see it starts to model them like that. And I have a column grid. Now, typically what I recommend with interns too is you go ahead and you measure, you copy or you select all of what you just did and you pin them down. Because the structure shouldn't really move willy-nilly. How many times people have accidentally moved a column? It's pretty common. And that could be pretty bad. So you want to make sure that stays where it's supposed to.
When we're setting this up, they should only be between, like, I guess adjacent floors, right? Like, I'm not gonna have one go 1 to 3. It's gonna go 1 to 2. Then I'm gonna have another one from 2 to 3.
For columns?
Yeah.
That's a good question. It's gonna depend. I mean, in this instance, for our purposes, I have it go from level 1 to level 3.
Oh, okay. Sweet.
Just because I don't want you to be in a position where you don't align them.
Yeah.
But in practical reality, if I'm building a 7-story building or a 6-story building on a steel, which is permitted, typically you're gonna stack the steel and the upper floors don't need it to be as wide. Why?
Less load.
It's less load. I have to carry more of the building each level I go down, right? So the columns are typically gonna splay out. We're talking about, an inch, 2 inches. But as they stack on the center line, that's what they would do. But we're not gonna do that today.
Professor, can you show us one more time how to pin them down like you did?
That one's easy. I'll go ahead and show you. I click one, okay? And up here, under modify, and pin it.
Modify. Thank you. Boom, baby. Perfect.
I remember now why I had it at like 34. It clashes with my garage door.
Well, that's the one you can just scoot over.
No, the door's gonna move. I don't wanna move the whole grid.
sure it's presenting that? Never mind. I think it was. Where did
Now it's stopped. You might want to share your. Sometimes when you share just that
so
one screen,
temperamental.
if you share your entire screen,
I will.
it might be easier. But then if you have personal stuff, then
Of course I do. I added a beam just for yucks, and look what it did. It put it exactly where I expected it. Yucks. Yucks. So if you're ready to add a beam, what you would do is you go to your second level, or whatever level you want to add a beam to. And similar to when we added the column, we go to beam, properties, and you gotta make sure your beam size is correct. So we were talking about how W12 is gonna be like at least what you're gonna need. So I went ahead and bumped this up to 1430, okay? Again, not gonna be grading you so much that you would know exactly what column you need or what beam, but understanding basic that it can't be a W8. If I were to go ahead and just pick any random column, I could go from one edge all the way through to the other because I'm more or less going to be using that the entire way. As I mentioned before, the easy way to check is where did it land, and in this case, it put it on the correct level. Now, originally when I did this, my beam didn't go in the right area. So what you could do is you can go to edit work plane and you can go to pick a plane and you can pick one. In this instance, it wasn't a problem. But if it is a problem for you, you'll actually see, depending on what model you're on, what mode, you can actually pick. I can go to work plane, pick a plane. Okay, if I go go to edit work plane, it'll actually, let's say, specify a new work plane. So you want it to be on level 2 in this instance, but it's stuck on level 1. You can actually go ahead and fix that. So I went ahead and took it off. Now it's on level 1. You go to my 3D view, you'll see it's on the other level. It's not where I want it to be. So if I go to edit work plane, I'll pick W2, and it will move it up. Now, you know, when it comes to structural manipulation, things get pretty crazy. So I just want to warn you. So big properties, you'll see here, I can do offsets to start and offsets to end. And what this allows you to do is have like angle beams and stuff. So if I have a starting offset of 0, I can have another offset of like -2. You'll see it actually puts it at an angle. Now, in this instance, this isn't really necessary, but let's say you're like, hey, I really want to do something with my roof, and have my roof at an angle. So I want the beams on my roof to have that angle. That's how you can do it, without confusing yourself. So what do you think the homework's going to be? Just out of rapid curiosity.
Something about electrical work, probably. Maybe plumbing, air conditioning.
Any questions? Roof beams don't have to be as robust. Why?
There's no live load.
There's less live load. There's definitely essentially less live load. Yeah, but it's more so that dead load is low. You're not supporting the floors, supporting the roof. You have some serious uplift potential. And so there's a t-shirt there. You don't want to be uplifted with your roof. You know what I'm saying? Like most people want to be uplifted. Give me an uplifting story. That's what it should be. Structural engineer, an architect asks a structural engineer, hey, tell me an uplifting story in this Hurricane Katrina. Spoken words, I don't know.
Homework cards. If that counts still.
I just came up with it. Thank you.
It's like, what's that Adam Sandler movie?
No, you're thinking of 100 Days of Summer.
Is that what that
100 Days of Summer, he was a greeting card writer.
Yeah.
That was Jesse Gordon-Levitt. His character he wanted to be an architect, actually.
No, you're thinking of Click.
Well, he is an architect. 500 Days of Summer, the guy was a writer of cards. And he...
Adam Sandler.
No.
Okay, but there's also an Adam Sandler movie.
Well, I can't be expected to know all the
Why
all the
not?
canon of Adam Sandler.
All 55?
I love Happy Gilmore. It's one of my favorites. Okay. So I think I'm just going to have you do it in your actual models. So you don't have to worry about the nonsense.
Thanks.
Huh? Do what? The structure stuff can be in your actual model. So you don't have to make it a secondary model.
Oh, you mean like the MEP file stuff?
Correct. You don't have to do that. So I know how much you hate that.
I have a small question.
You have a small question?
If the beam, if it's not showing on either of the floor plans, and we're sure
Look at 3D and see if it's going below the floor already.
it's right below the floor.
I know, but I told you what to do. You gotta make sure you put it on the right level. And in order to do that, you gotta select it, go to edit work plane.
Yeah.
You gotta pick the correct level.
All right, let's say I did that. I'm at the right level number 2. Okay, works perfectly on the 3D view, but then I
Sure
want
you don't see it on this plan?
Yeah.
What's your view? Okay, so this is just like everything else. If you do fine, guys, you have to pay attention. If you go to coarse, it will show up as a line. If you go to fine, it will show it as an actual thick number. And then if you go to shaded, you'll start to see it a little bit better.
now
I'll
you
show you what's like on the floor.
you can't select the beam either, can you?
Now I can. I can go to this view and select it.
Okay. That works. Alrighty.
Any other questions for me? Yes or no? Let's write the homework together.
We have homework assigned for the next class?
Huh? He's about